In this video, I want to show you some functionality that you can achieve with enums in Java. Enums are quite powerful. They can not only contain some basic values, but they can have additional functionality inside your enum. Let me give you a few examples. And let's start with a few example use cases where I used enums and extended functionality inside an enum. The first one is api.py4j.com. It's a website providing information about the different Raspberry Pi boards. And as you can see, this actually looks a bit like a database, but actually all the data inside here comes from a library, a Java library. Why we've done it like this is because we want to use that data in applications that can run offline, so that all the data is available inside the code and you don't need to call an external service. But with this API website, we actually show what is inside this library. And all the values here are actually defined inside enums, like which board types are available for the different Raspberry Pis, the header versions, what's inside a header, these pins on the Raspberry Pi. So all this is included in a Java library as enums. Another project I'm working on is Lottie4j. Lottie is a file format, a JSON file format to define animations. I want to achieve a Java FX library. Still a lot of work to do there, but that's where I am now. But inside this library, again, a lot of enums are used to define the different types of animation, of blend modes, of other data which is inside these Lottie files. And as you can see here, a blend mode has a name, but it can also contain a value and a label. So again, enums providing a lot of additional functionality. Another project I'm working on is, together with my son, is a website for drummers, and we have categories here. And if you look at this drop-down box, these categories again are enums, and inside the enum, both the name, the color, the text color, the icon, all are defined in this enum, and that allows it to easily reuse it for other use cases. So here you have a category for the videos, which is a full label. But below the videos, you see the same icons, but only the icon. So you can use the enum in different use cases in this case, to visualize different types of icons or an icon with the full label. Now, let's dive into some code and see what we can do with these enums. I have this very basic code here ready to use. So it's just the main method that we have, and we can print out something. Now let's see if we can run this. Okay, we get our system out. That's all we need at this moment. So I'm gonna do a lot of copy pasting here. I prepared some stuff. What we typically see in a lot of applications is this kind of static defined values, fixed values that can be used for certain functionality. Like in this case, we have a level and we have different levels, an info level, a warning level, and an error level. You will probably recognize this from a logging framework, for instance. And then if we have, we can output this. And if we run our application, we get the level 1. Now, this is a bit dirty because you have 3 lines of code, and it's not really the best approach to do this as a programmer and work in this way. And Java has some very neat way to achieve the same thing with an enum. So let's remove this again. And now we have an enum with a level and then the values inside there. Now the definition is that you use camel case for the enum itself and uppercase for all the values inside the level. Now you see that we have an error here because this is not recognized. And now we have a level and an info, and one of the main advantages that you immediately see is if you type the dot, you get all the possible values there, which is easier to extend than what we had before with the different integer static values. So if you want an extra one, unknown, for instance, come on, we have this fourth option available here. Now, if we run our code, we get unknown as the name. So this is already the first step, making it cleaner code, easy to read and very easy to use. Now, what can we do with this? For instance, we want to have a value assigned to it. And let's print out. So we have the level info. And we have an extra method that checks the level, and depending on the level, it will output a certain value, an integer value. A bit going back to that first example where we had the static defined integers, we have a helper function now, a helper method to return the values. Let's see if this code wants to run. Okay, we get for the level info in our methods, it returns a 1. Info, warning and error are defined here. So if we go to unknown and we run our application, we get the level 0 because we end up here as unknown was not defined in here. So we have a helper method to convert our enum to a number. Now, actually, this is not required to do it like this. We can have a very much more smooth approach, much cleaner code if we combine all this inside the enum. So let's just remove it again. And let's extend our enum with values. So we can add attributes to each enum value here. So then we need some value. And now we need a constructor. So what we say here is when our enum is defined, that each possible level gets a value. And this value is created in the constructor. And now we can have a public getter, get value. Now, instead of this helper method that we used before, we can just call getValue, which will return the value from inside the enum. Let's use the error. We didn't use it before. So if we run the application again, you see that we get level 3. We went to the error, and error is indeed value 3. And we can go further. So let me check if I have some extra code here that I can copy paste. I'm a bit a lazy developer, as all good developers. So what do we have now? As you can see, we have 3 levels: info, warning, error. They have a severity, which is the value that we used before. They have a label, and they have a color. In case you would have a graphical user interface where you want to display the amount of the logging levels, then you can actually use a color there. And we have 3 variables where we store these values, and we have getters to request all of these. Now, let's replace the code in our main. And here you see an extra use case of the enum. We can actually loop through all the values that are defined in the enum. So if you have the values, we can just, for each level in all the level values, we can print out all the data. Now let's try this, save. And we actually get a lot of data just out of the enum. So for the info level, we have a severity of 1 with the label informative message, and the color, it's not a hex representation anymore because inside the enum, we define it as an integer. If you would have this in a graphical user interface, you would probably convert it to a hex value. So you see, we have a lot of functionality inside the enum. And now it becomes very easy if we have to define an extra one, which is critical. And the severity is very high. The label is, this is a big problem. And as a color, RGB. So we give it full red. So we can very easily define, we can very easily define another level in our enum. You can also use enums to avoid booleans in a lot of use cases. Let me give you an example of that. What you will see in a lot of applications is, for instance, a customer class. So you have a customer has a name, and it has a boolean active. So the customer is still active or not active. It should be included in some lists or not. Now the problem is you could have a customer which is active but has been suspended because he didn't pay the bill. So that would mean that in the next version of your application, you're adding an extra boolean. But actually all the suspended customers are still active. So that means that you have two booleans and actually you only need one value. Now this can be made a lot easier and future-proof if you use an enum with the customer state. So if we go back to the code and we add a customer state, so what we have here is a customer state, and it can be active or inactive. That's the first use case. It can be Boolean, true or false, active or inactive, but actually we have an enum that represents the state of a customer. So we have one state inside the customer. Now in the next version, if we need to add the suspended state, we only need to have an additional value here, suspended. And every customer can now get the suspended state, which makes it a lot easier to maintain. And it will also be a lot easier to define a new customer or change a customer to avoid that you have a lot of true false parameters when you call a customer. So it's really clear from the beginning that a state has a certain list of possible states, and it's very easy to maintain and a lot more future-proof than using booleans. Let me show you one more thing, and that's using enums together with JSON parsing. So getting from JSON data into Java objects and from Java objects back to JSON data. I'm going to use faster.xml, a library to convert this JSON data. And I will also be using gbang. Gbang is a tool that allows you to run code with dependencies without the need to create a Maven or a Gradle project. In the descriptions under this video, I will add more information about gbang, how you can use it, and some blog posts referring to this. I will just show you the code and go through it and then also show you the result. What is important to run Java code with GBang is that you have this additional first line here that tells GBang that this is actually Java code to be executed. Also a list of dependencies. So in this part of the code, it is declared that I want to use faster XML JSON and then the versions and what library exactly. Now GBang will then download these dependencies for me, so I don't need to create a full Maven project. It will import everything. So we have the full code available here. I will just go through it. Inside the main application, I define a JSON. As you can see, it contains some log messages. For instance, a program has been running and this is the log output that it has created as JSON and somewhere stored as a file. But here I just declare it in my code just to test this. So each message in this JSON has a level, a log level, the timestamp when it happened, and the message. So my program started, it has an error because the file was not found, and then there was an error. So I have 3 messages here, 3 log messages. Now we want to load this data from JSON. So I'm going to convert this JSON string into an array of log messages and then just print them out into the console to see if everything was loaded correctly. Now let's take a look at a log message. A log message is here defined as a record. It has a level, a timestamp, and a message. And for now we will ignore the zoned datetime. That's a bit of tricky thing in JSON parsing. If you want to use Java zone datetime values, you may need to do some additional things like formatting this, but for now I will ignore this. But this means that a log message has an enum level along as the timestamp and a string as the message, which is exactly as we see here, a level, a timestamp as a number, and a string message. Now we have this level here. Let's take a look at the level itself. As said before, it's an enum. It has this info, warning, and error defined with the severity 0, 5, and 9. And actually, the 0, 5, and 9 are the values that we see in our JSON. So Java must be able to link this level null to the enum info or to the enum warning. Now, how does this happen? The rest we have already seen before. We have the constructor and we have the getters. But actually we have a JSON creator here. And the creator will be used to read back the JSON value and return a level. So it gets an integer, the severity. It will loop through all the values of the level. So these 3. And it will check on the severity, find the first one and give it back. Of course, we need to be aware that if something's wrong in the JSON and we have a value 1 and there is no level with the severity 1, it will throw an error. Okay. Now, if we look further in the code, we also want to generate the same type of JSON, and we can just have these log messages that we read before. We output them back to a formatted JSON. I use here the writer with default pretty printer, and the only reason for that is that we get a JSON which is formatted in a nice way so you can read it easily. Otherwise you just get one long string, one line with all the JSON data. And we go back to the level because here we have the JSON value defined. That means that when writing a level, an enum level, back to JSON, this value will be used as the data included in the JSON. Now let's see if we run this. Oops. Let me clear this. So instead of using Java and the class and the file, I now use gbang. So gbang will check. Let's go back to the beginning. So gbang has been executed. Because I executed it before already, my dependencies are already downloaded, so it can immediately start the application. Now we see that the data loaded from the JSON is a log message which happened at this timestamp with a severity informative message. So severity 0 is an informative message, and the message was program started. Then we have a warning message and we have an error message. So the JSON that we have before, this JSON, is converted into 3 log messages. So our Java program can handle them as Java objects and output them here in the system out. Now, if we go to the next part of the code, here, where we generate JSON from the Java objects again, we see that we indeed get the same kind of JSON that we expect. So level 0, level 5, level 9 with the timestamp and the message. So this level 0 is something we get thanks to this JSON value here, the severity. By the way, it's red here in Visual Studio Code because it's not a Maven project, so it doesn't find all the dependencies also here, but actually that's what gbang solves for us, and we can just run this code without the need to compile it ourselves. gbang takes care of this. Okay, this is all I wanted to show you with Java and Enums. There's a lot to learn there, and this is just the first part, so it will bring a lot of extra power to your application if you use this kind of structures and add some additional value inside your Enums. Have fun with it. The links to the post, to the blog post and the source code are included below this video. Have fun, experiment, and I hope you learned something.